another Doppler effect. Let's say an ambulance with its siren on moves at a constant velocity towards a person standing next to the road. So the velocity of the source is there, is moving, but the velocity of the listener is 0 meters per second. And then let's talk the frequency. Now the person measures a frequency. Now the listener measures the frequency, which is 110% of the frequency of the sound emitted by the siren. Of the ambulance. So this listener is hearing 110 divided by 100 times the frequency of the source. That is what we have. And then, by the way, the frequency of the source is not there, but we know that this listener is hearing 110% of the frequency of the source. So it means because it's towards, so the listener will hear more than, that's why saying 110, more than 100% of that. So name and state the phenomenon observed. So of course it's Doppler effect. And then it's the stating is saying it is a change in is the change in the frequency of a sound wave when the source of a sound is moving relative to the listener. But if the speed of sound in air is 340 meters per second, calculate the speed of the ambulance. Now they want the speed of the ambulance. With this information, we want the speed of the ambulance. So of course, let's see what we can have. It means the speed of the frequency of the source will be the frequency of the source. Fine. Our formula says frequency of the listener equals to v plus minus the velocity of the source, not source, listener, over v plus minus the velocity of the source multiplied by the frequency of the source. Now let's put in the information. The frequency of the listener, they are saying, is 110 over 100 multiplied by the frequency of the source equals to, this is 340, and then the listener is not moving, over 340, then minus, why minus? Because they say it's moving towards here more than what is produced here. So rather we're going to have the velocity of the source multiplied by the frequency of the source was not given. So now what we can do, we're going to divide throughout by this frequency of the source, that will be cancelled out. And then now, of course, we can try to do the cross multiplication and see what you get. So we can say 110 into 340 minus the velocity of the source equals to 340 multiplied by 100. Right, of course, that will be 340 minus Vs equals to 340 by 100 all over 110. So, of course, we can have 340, then we bring this on the other side minus 340 by 100 over 110 equals to, now this will be the Kcn. Right, let's press our calculator and see what we get. So let's check with our calculator. It's saying 340 minus, and then we have 340 by 100, then we say divide by 110, then the speed then will be 30,90, is it 90, 90, that is 91, because it's 90, 90. .91 meters per second. Now that will be the speed of the sound source. How will the frequency measured by the person be affected if the speed of the ambulance is increased? Now increase the speed of the ambulance. Now if we increase, the ambulance is the source. Now if we increase this speed, let's get the number. So we had 340. Then we subtracted 30,91. And then if we use our calculator, 340 minus 30,91. So we had 309, 309,09. Now they're saying the speed of the ambulance is increased. So if it's increased, let's say to 40. Now when we subtract here, the answer will be 300. Now it means the denominator is decreasing. So if it is decreasing, then what will happen to the output? So it means the frequency or of the listener will also increase. So they're saying, how will the frequency measured by the person affected? So of course we'll hear an increase in frequency if that will be the case. So from these numbers here, it's just as we divide by a smaller number, then it means the frequency of the listener will be more high.